sewer design. That's okay, Jack, no problem. So there's a little video at the end of that with Nancy talking about how they made those decisions and why and how they moved forward with it. That's okay. Everybody's all right with that plan? Perfect. Then I will get started. So as I said, just a quick agenda, and I'm not going to be totally formal. Actually, I'm very informal. So if at some point along the way you have a question, jump right in, right? You won't get me off base. It's really hard to get me off track when I'm talking about pressure sewer because I actually get quite passionate about it. So jump in and feel free to interrupt me. I'm going to start out with a little video that we've made, and I find that's a really nice overview of pressure sewer. It'll give you kind of probably answer some of your questions right off the bat, and then we'll just we'll have some discussion around the rest of the slides. Maybe by turning that on. I don't know. We're going to get the volume on it though. Oh, hang on. Technical difficulties. Let me see how it's to share. Let's show that. How do I get it to share on the Zoom? Sorry, guys. Screen share. There should be a little checkbox that says share audio. Yeah, there should be. Oh, that's a better shot.
Central sewer system that can be installed on any terrain, flat, wet, rocky, even on sites with dramatic.
Okay, that's not going to work.
The Extreme Series Wrangler.
I did not. We'll try it. I don't want to log down. If this is going to be the hold up, then we'll just skip the video. I'll give it one more shot and then we'll just keep going.
Today, we're waking up to a connection.
We'll skip it. Just mute myself here. That's okay. We'll talk about it as we move forward. So we'll talk about. I am so I don't know that. Okay, we'll talk about the history of pressure sewer. It actually all started back in 1967. What's I know it's really bad. My speaker's off on my laptop. I am muted on my laptop. Do we have to have the microphone? Oh, for the Zoom people. Because I can certainly talk loud enough that everybody in this room would hear me.
Sorry, no problem. Sorry, let me try something.
Yeah, because my speaker's muted.
Where is? Okay, try this one more time.
Skip the video.
Yeah, that's right.
That's okay. We could send people the video. It's actually on our website. Super easy to find. We can direct people to that. So anyway, the history of pressure sewer. Back in 1967, the American Society of Civil Engineers was doing a stormwater separation project. And that was in upstate New York. So they had a way of working with the stormwater itself. They knew how to handle that side of it. They really didn't know what to do about the residential sewage. So they went to General Electric, whose research and development department is up there in upstate New York, just outside of Albany. And at that time, General Electric was building an awful lot of appliances, all kinds of different appliances. So they went to them and said, can you invent something? Can you create something that will handle this sewage? So there were 6 engineers on the project that took this on. And if you look on the right-hand side, that's one of our original founding fathers. And that was the original prototype of what a grinder pumps. That's the first grinder pump station that really existed. And it worked really well, but General Electric did not want to be in the pressure sewer business at all. And so these 6 engineers bought their intellectual property off GE, moved just down the road, and formed EOne. We opened the doors of EOne in 1969. So yes, we're celebrating our 55th birthday this year. And that's where it all began. Obviously, we've changed the design, we've made it better since then, but that was the origin, the origins of how it all started out. One of the key things about pressure sewer that people start to worry about is it going to be reliable? Is it going to grind up what it's supposed to? So what we've done is we work with the National Sanitation Foundation, and we have them certify us every year. If you look at this list of items, and you'll see that some of these things should be in sewage, some of them shouldn't, but invariably in sewage, items that shouldn't be there still end up in there. So NSF has chosen this list of items, and they recertify us every year, and they come along and they throw all these things in our tank and prove that we can grind them up. So, if you have concerns about, will it handle this, will it handle that, though the items that maybe are in the question of your mind might not be exactly on the list, I hope it gives you a good idea of the types of items that could be there that our pump will indeed grind up. To give you an idea of what it's going to look like and what the equipment involved is, we'll start over on the top right-hand side, and what you'll see is an alarm panel that's mounted on the side of the home. Traditionally, that's where it's going to go because we like it to be within sight line of the station itself. And that's really for servicing down the road if that's necessary. But that's where we really want it to be. And so that's also where the power for the pump is going to originate. So if you look, you'll see a conduited pipe that comes down at the bottom of that alarm panel, and it comes over to where the station is. And so you've got a power cable that's in that conduit, and it comes over and actually connects into the pump, and that's where the power comes to grind the system. Lower on the right-hand side, what you'll see, that's a 4-inch pipe that's going to come out of your house. Right now it goes into a septic tank or a cesspool, but that's the 4-inch line that brings the wastewater out of your home, and that'll bring that over into the tank of the grinder pump station. And once it's in there, the grinder pump itself is what's going to macerate it up, and it grinds it into a very small, fine slurry, very small pieces. We no longer have any large solids. And that is the advantage of doing a pressure sewer system, is it allows you to use very small diameter pipe. Makes the construction and the excavation not only a lot less expensive, it makes it a lot less invasive in your community. We don't have to close a lot of roads. We don't have to make really big disruptions in your yard when we do small diameter piping like that. So it'll grind up into a slurry, and then you'll see sort of halfway up that tank, there's a pipe that comes out the left-hand side. That is the lateral discharge pipe that would take it out to a pressure sewer force main that would be along the edge of the road. Buried, obviously, but along the edge of the road. So that's the way it's, oh, now Zoom's kicked out. Sorry, it kicked me out of your Zoom meeting. I'll just reshare. Sorry, I don't usually have so many technical difficulties, but here we are. Okay, back to it. Right, so that small diameter, now that pipe itself that goes out to the street is only 1.25 inches in diameter. And the reason it can be 1.25 inches in diameter, again, is that the wastewater itself has been ground into that fine slurry, right? There are no large particles that it's handling. I won't get into pipe types with everything because I can be a little geeky about that. But the type of pipe we always recommend you use is also very flexible. not flexible, like you could just bend it, but it can go around trees, it can go around rocks. You can be very flexible with where you put it, the path through your yard. And again, only 1.25 inches. So it's not going to be a big trench that gets cut through your yard. And then it goes out to the pipe in the street. And that's what then takes it away to whether we look at working with the county, excuse me, county treatment plant or a package plant. These are things that as a community, we're happy to help you work through. It has to go somewhere to get treated, right? And not just end up in the ocean untreated. One of the big questions that people always ask me is, what is it going to look like in my yard? Especially when you're in a beautiful community like that. There's a lot of people that have put a lot of time, effort, and probably expense into making their yard look really, really pretty. And we don't want to be the eyesore. Now, we have a lot of very exacting communities here on Hawaii that have used pressure sewer. If you look on the left, though the lid itself is a little greener than it is in that picture, it's kind of an older picture. If you just had the tank buried in the ground, all you're going to see is the top of that lid. If for some reason you actually don't care for how that looks, we do have a couple of different ways of hiding it with basically a fake rock. I would ask, when you're walking through here, did anybody notice where we've put a grinder pump lid along here? I'll show you when you get back outside when we finish, but we actually have outside in your yard right now. We didn't bury anything in your churchyard. It's just the lid, and we put the rock over it. And in a way, I was actually hoping that maybe nobody had noticed it, because it really can look very unobtrusive in your yard, and it can blend easily into the landscaping that you've already got. One of the other things that homeowners always worry about, and rightly so, is warranty. We actually, we pride ourselves on having the best warranty out there in the business. We have a standard, everything comes out with 2 years. 2 years on parts and labor. And that's fairly uncommon that people would cover labor, but we do. So that means if a service tech did have to come out and do a warranty service call, not only are we going to provide the parts for that at no cost, we will also reimburse the serviceman for their time and for their travel. So it ends up being no cost to the homeowner. And with the program that we've managed to develop now, we can actually get all of you folks a 5-year warranty on your systems in a residential setting like this. And we work very closely with the installers and the contractors, and we put them through quite a rigorous certification program. We train them up, we test them to make sure they are paying attention, and then we know that they're going to put it in right. Over experience, over the years, what we've all found is that if there's going to be problems in a pressure sewer system, very often it's because it was poor installation. Getting the installation right is key to making sure you have a very long-lasting and reliable system. So we'll certainly work with the contractors to make sure that they get that done right for you. Oh, and then I have this lovely video I was going to show you of Nancy, but clearly videos are not my friend here tonight. But it is, again, also on our website. What I'll do is I'll make sure that your organizational folks here have the link to our website that will take you to the videos that I was hoping to be able to show you, but they're certainly readily available on the internet for you. So we'll pass through that. Like I said, I wanted to keep the PowerPoint very short and sweet. Shorter because we didn't watch the videos. But yeah, so thanks for giving us the opportunity to talk. What I'd like to do is hear what's on your minds. What concerns do you have? What fears, what hopes, and how can we help you? Yeah.
So the system like this, who is your customer? Is it or is it a homeowner association?
It varies. Sorry, I'll answer that from over here. It really varies by area. I cover Western Canada, the US Pacific Northwest, Hawaii, Australia, New Zealand, Malaysia. And everybody does it differently. And even within countries, different areas do it differently. There's a lot of places in the mainland US where the municipality owns everything. They buy the equipment, they operate it and maintain it, and people pay for it through their, their taxes or their sewer bill or something like that. There are other areas where it's very common where the city would own the force main, which is the pipeline in the street that will take it away, and they would own it right up to the property boundary. And then the homeowner is responsible for purchasing the system and then on, operation and maintenance of it after that. So it's really depends on what kind of relationship you end up setting up with your municipality. Right? How much do they want to be involved? We make one pump, and it's a 1 horsepower pump, so it's a very small motor, and it runs. In a community like this, you're probably looking at it making about 11 gallons a minute, 12 gallons a minute that it's going to pump out. As the water comes into your tank, like that tank acts as a buffer. So it's every time you flush your toilet doesn't mean that the pump is going to run. It comes with factory preset on and off levels. So when the water level in the tank reaches the correct level, the pump will turn on. It'll run for about 60 seconds. And then pump down the liquid, the pump will turn off, and it won't run again until the water reaches high enough in the tank to turn it on again. One grinder pump per dwelling.
So what do we do with condos?
With the condos, what we do is we do a larger tank and we put more pumps in it. Right. So when when I drive through here and I see the condos, the largest tank that we make is, well, in an HDPE, it's 480 gallons, and we put 4 pumps in it, and 2 work at a time, standby and duty pumps, and that's how we handle large operations. We do strip malls, we do college dorms, we do townhouses. You can talk to.
Just so you know, Colonial Heights, there's a seniors community building over, several buildings over there for elderly housing, and we have I think there's a half a dozen what we call quad stations, which has 4 pumps in a station to handle each one of the buildings, and I think there's probably like at least a dozen apartments in each one of those buildings. So that is a larger capacity.
And I guess another example would be if you look at, say, Kona Village Resort, right? They've got, some kind of single family hollies, and then they have larger ones that you could have a great party at. And if we had a look at how we've done that, depending on the size of the flow, the amount of flow that will be coming from the building helps us determine what the size of the tank will be and how many pumps it needs to have. Absolutely. Yeah, sure. Better? Okay.
So what provisions do you have for power failures?
The pump, the tank itself is designed to have 24 hours of storage in our standard systems. We do have tanks that are designed to have 72 hours of storage. What we do is we work with the homeowners in the area to determine what's typical. If you have above ground power lines and maybe you expect on a regular basis that you might get a power outage for 2 or 3 days, then we'd recommend the tank that has that extra storage capacity. If it's a place often with buried power lines and the power is very stable, then we'd go with the one that has 24 hours worth of storage.
And all your grinders are 220 volt, correct?
240 volt is the majority of what we do. We do have a 120 volt version. A 240 volt motor will always last longer than a 120, right? That's just the physics of a motor. But we do have that option for homeowners that can't pull 240.
Also for your power outage question, what Engineered Systems likes to do is we like to standardize a generator receptacle in the alarm panel. So in case you guys do have longer blackouts, you can pull up a generator, plug it in, and it'll automatically transfer over. You don't have to do anything else. You just turn the generator on and then your pumps will start going again.
Go ahead.
We've been talking about this. We're talking about a tank. So is that 2 separate units? And each property has both,
Yeah, if you look at it, the tank itself is what, and I'll go, but let me go back to that slide, actually. I'll show you again what that looks like. Come on, go back there. There we go. This is being difficult today. That's okay. So the tank itself, and that's what the lid that I was talking about. So you've got the alarm panel on the home, it comes over to that tank. The tank is buried. So what you'll see is just the top of the lid. But yeah, a pressure sewer system has to have a tank. That's what's going to collect the wastewater from your home, right? So that's that 4-inch pipe that'll go in there, and the pump resides inside that tank. It's one unit. Yeah, yeah.
my other question is if in a property, a house and maybe a rental unit, so there's maybe two separate structures on the one property. Does each one of them get a separate one of these then?
You're talking about like an ADU or something like that? Yeah, that's very common. We can pipe an ADU into just the single tank. You wouldn't need to have two. You're welcome.
So I think one of the things about the EOne Systems and the kind of need that you might want to go over for everyone is because the solids in the line, you've got to produce much more head pressure. So the EOne pump has.
Oh, I'd be happy to. I just didn't want to.
Because I think that's
Sure,
because you've got such long runs
you do.
and very low flows at times. So the material will separate out in the pipe. And then you gotta.
Sure. Yeah, so the pump, and you're absolutely right. The way that the question was about kind of the pumping technology. What's unique about the EOne pump that will allow it to push long distances that you're going to have? And obviously we want to also avoid solids settling out in that pipe and creating clogs and constricting the pipe. So I can address all of that. The pump itself, if you look inside, and we're not going to take it apart for you tonight, but if you think about if using a post hole auger to dig up a hole for a fence post, and it has that that corkscrew design, and every time you turn that auger with your hands, a fixed amount of dirt fills those gaps and ends up coming up out of the hole. Our pump works exactly the same way, though we don't have those sharp cutting edges on it like a post hole auger does. It's called a progressive cavity pump. So every time the motor turns the shaft inside the pump, a fixed amount of fluid moves up and out and discharges out through that line that you see that goes out to the force main in the street. What that does is gives you very predictable and very consistent flow. It also makes it a very efficient system. So one pump with our 1 horsepower motor on flat land can push 2 miles. If it needed to go straight up, it could push it 185 feet in the air, just with the working mechanism of one single pump. And then what happens when you lay out a system is all the, each progressive pump pushes it along and along and along. So you can get, like I said, up to 2 miles. If you need to go farther than that, there's different mitigating things that we can do. We also work very closely. We at the factory and our engineering team, we work very closely with the design engineers, because one of the key things in making sure you don't get those solids settling out is the size of the force main pipe that's going to be down the street. Now, you know that the single pipe going out the lateral is only going to be 1.25 inches. Out in the street, it might be 2 inches. We do a hydraulic analysis to determine what size that pipe needs to be. But 2 inches, maybe when you get closer down to the discharge point, it might be 3 inches. But what we do is ensure that the pipe is sized appropriately to get a scrubbing velocity of at least 2 feet per second. At 2 feet per second, that it self scours the pipe and it doesn't give the solids an opportunity to drop out. But it's very key to get the engineering right at the beginning, which is why we spend so much time dealing with the engineers at the beginning of a project. Did that answer first? Did I answer your question?
I always thought it was 3 to 5 feet per second.
So minimum scouring is 2. You can get, 3's fine. 5, you're getting a little bit up there. We really want to avoid really anything higher than 6, just as a general design principle, because you do start to create kind of friction along your pipe, right? And you can start to, if you're using HDPE pipe, it's not such a big deal. But you want to make sure that you're not actually eating away the inside of the pipe by going too fast with your slurry.
It's on? Yes. So especially in the case of the model where your customer is the individual dwelling owner,
Yes.
what protections do you have such that one individual person who does not maintain his system correctly doesn't cause problems for the whole rest of the system?
Well, that's actually the beauty of pressure sewer, because if somebody doesn't maintain, or they're flushing things that they shouldn't be, the problem actually remains right on their yard. Everybody else's will be pumping out into the force main. And if somebody hasn't maintained their system, in essence, what will happen is that they will not be pumping. If they've let their pump fail, it won't pump out into the force main. If they're putting chemicals or different things, fats, oils, greases, that type of thing that shouldn't be in the sewage, that'll collect in their individual tank at their yard. It actually helps keep yours cleaner, because then that means that those items aren't ending up in the community's collective pipeline. Scotty, did you have something to add?
The first installation in Hawaii of a low pressure sewer system, after years of song, was in Mapunapuna, which is right next to the airport in Honolulu. The Damon estate needed to re-sewer the area. It was flooding every year, and ultimately we ended up putting in low pressure sewers. What the municipality, who had been, fighting the thing tooth and nail the whole way, what they found out was that all the auto body shops and the paint contractors and the engine repair shops and all of those guys, they were throwing their grease and their solvents and everything into the sanitary sewer. When you put that stuff into an E1 unit, it runs for a while, but eventually in a very short period of time, like less than a year, you'll melt down the rubber components of the pump. So what would happen is these guys that were in violation of the municipal rules, they would call, and one of our service guys would go. Because it was the first install, we were trying to kukua as much as we could, so that we would, get the community behind the house. So we would go into the facility, pull the pump out, and every piece of rubber on the pump is gone. And
But people just come down and, like, they're painting the house, they just dump it in there. The toilet.
You're misusing the sewer at no charge. The next time it happens, municipality, and we had that happen a number of times. Different,
It just absolutely happened in Puako.
oil down the used automobile oil down the drain, all kinds of stuff. But what the municipality found out was that the system actually prevented these guys from misusing the system, and their operations at the treatment plant improved because they weren't having to deal with all these tramp materials that were coming in that shouldn't have even been in the municipal sewer system.
Frame are we looking at as far as getting the go ahead, study, research, installation for a community this size, about 160 homes and condominiums to completion? What would be about the time frame we're looking at?
Cost.
Bob having done enough, because everybody's local government operates a little bit differently. It's hard for me to know exactly
Yeah.
what works here.
How about
and
10
I think
years?
Bob probably has greater,
Well, I did, Kona Village, we had 63 systems. And we probably were under construction with those systems throughout the whole process. Because we did it in phases. I would think here could be 18 months to do that job. Maybe
18 years or months? Well, that's not too bad.
So you're double here, basically, or a little more than double. So you could be looking at upwards to 2 years. It kind of depends on how you attack it. If you're going to break it into sections and concentrate on the section first and that type of thing, get the mains done. And then I'm assuming you're going to have a package. plan.
Where's it go?
That's another subject.
yeah, and I think, they're in early stages of kind of planning and envisioning here. So I'm not sure if the county will agree to take the sewage or a package plant, right?
Or
They'll
they-
say no.
And they could use the product. That's not the problem. Yeah. Okay.
Yeah. Thanks, Bob.
Yeah, thanks, Bob.
And I have a question next.
Okay.
The county is replacing our drinking water line right now, or pretty much finished. And they have offered for us to use their old water line as maybe you'd say conduit for
It's a sleeve in
as a
essence.
sleeve, right?
Sure.
So slip line.
Yeah.
Can you do that?
Absolutely. Now, to answer that definitively, first I'd need to know what size the water line is.
I think it's 6 inches.
Yeah, we can do that, no problem. The diameter of your low pressure sewer force mains, with this number of homes, you'd never get anywhere near 6 inches. So yes. Yeah, that's the only
thinking wrong?
caveat. If it's actually collapsed anywhere, that'll be a little trickier. Yeah.
No, tree roots, everything.
Sure.
That's what we're replacing
Sure.
it, right?
Yeah, it's going to be a way to do it.
Yeah.
Use it as a carrier pipe. Our pipe is going to be like worst case scenario 4 inches. So it's going to have 2 inches clear on each side. You slide the HDP pipe in there, and then you can slurry in concrete to encase our pipe, and then the carrier pipe. Even if you've got a couple of sections that are bad, we could fix those. And then you slurry in the grout, and then basically it forms a forever pipe to take care of it. Yeah, there are two things that would be great about that. Number one is, you would save the cost of the directional drilling that you probably would need to do the segments of the main.
Well,
And
they've already slurried over the road though.
so you're going to save that cost, number one. And number two is that, you're going to have an install that's probably going to be good for a really long time.
Because it replaces the water line, we're gonna have a new street. And so we're gonna have a new street probably by the time we start doing the sewer line. So we want to be as undisruptive as possible. So that's one reason we thought using the old abandoned water line would be a help.
This is two questions. One is, I can't really read your diagram up there, but is there backflow protection on the pump?
Yeah, here, I'm gonna go to my. That's an excellent question. It was about, is there any backflow
Yeah, I haven't.
prevention on the pump? And we have a redundant check valve system. So I'm gonna walk over here just to point. This here is a boundary kit. It's a 3-part valve assembly. It has a check valve, it has an isolation valve, and it has an inspection cleanout port. So that is placed right before you tie your lateral discharge line into the main. Because in essence, a pressure sewer system is under pressure with other people's sewage, with everybody's sewage. And you don't want that coming back on your yard, right? So we put a check valve assembly right where you're going to, right before you tie into the main. The pump itself also has a check valve on it. We have a redundant check valve there, just, you know, in case something ever did happen with your check valve at the boundary, it'll stop it from coming back through your pump. And you
Near
don't
your
want to
house.
end up with that, you know, coming up into your house. So we put a check valve there as well.
But
There's an
that was really my
anti-siphon
question.
valve built into that check valve assembly in the pump as well to stop it, in essence, creating a vacuum and coming back.
The other question is, and since you want to be technical, how many diameter of pipe from the pump can you go before you make a turn?
Oh, now we're and I actually won't really geek out on you too much. The diameter of the pipe before you can make a turn, you're thinking about friction losses and water hammer and all those sorts of things. Fantastic question. That's really, that's very relevant if you're looking at centrifugal pump technology. And that's where, like I said, I don't want to get too into pump dynamics here, but a centrifugal pump is like a fan blade, right? It's got what we call an impeller, it's a blade, and it turns and turns, and that's what dispels the fluid out of your tank. And because of just the physics of how that works, there's a pressure and velocity relationship with a centrifugal pump system.
Hard for me to
So
eat
if you
while we're
get
talking about
too much
shit.
friction, or if it's coming out and very close to the pump, hits a 90-degree turn, a couple of things will happen. It puts a lot of head pressure on the pump, resistance pressure, if you will, on the pump. And what that does is it slows down the flow rate that pump is able to eject from the tank. Because we're using that positive displacement pump, like your post hole auger, it really doesn't matter up to a pressure of resistance pressure of 80 PSI. That pump, our pump, isn't going to care where those resistance are. So if you need to make that turn with an HDP pipe, you can go around, your well-established tree or your rocks or whatever it is. There is really no set distance, and because we're only going at 15 gallons a minute, so it's not like this is rushing out the way it would, say, out of a fire hydrant, right? And you're going to hit a wall, you'll get water hammer that comes back.
Yeah.
With sewage at 15 gallons a minute on a progressive cavity pump, that's not going to be an issue.
Okay, the reason I ask is because you want to get up to a good depth, because down at 3 feet or 4 feet, it's pretty much all lava. And so you want to get up high enough to be in the dirt. So that's why I was curious what the rate is.
The first thing we do coming out of the tank is like within 12 inches or so, we elbow up because of this access to that line.
Can't hear anything. It's kind of stupid.
That curb stop valve.
That excites you.
It's just up my alley.
We don't have to worry about the frost line, obviously, here. We can run 2 foot below. We just bid the Honokaha Boat Harbor. We're going to take all of those to EOne stations and pump over to Cal.
Who paid for that?
Manhole right on the main drag. We're going to drop into that manhole. And, if
Who paid for that?
Kind of think about how far that is, no problem. And we're going to pick up all of those businesses as well as the comfort stations that are in the boat harbor. And it's all going to get ground up, pumped over, and then tie into the manhole on the main drag on Queen Kamalana. And then from there, it'll gravity into the Kealakekee plant.
Okay, this is my last question.
Ask away.
In reading about EOne pumps and some of the areas that have been done back east, they feel that they are required to take them out every now and then to look at what they do. Why did you say big one? Yeah, big one.
Can't hear it now.
I can't hear it either. It's up as high as it goes,
It's
Greg. Oh, you're complaining. I can't do it anymore.
I know you can't.
Sure. We'll start with what is a pig, pigging a line. What that means is you have had solids deposition in your pipeline. It starts to become an obstruction. And then pigging is a small mechanical object that's just slightly smaller than the inner diameter of the pipe you're going through. And, your public works department or whoever would force that pig through. And in essence, it's just pushing everything that was obstructing, pushing it forward till you get to a clean out point and they can actually get it out. It's using it to clean out a line. I'm not sure which exact community you're talking about that's having to pig their lines that often. If they've had a very slow build out, like I said, we would design the pipeline sizes to have that at least 2 feet per second scrubbing velocity, or 3, whatever makes sense hydraulically in that pipeline. There are times when, not so much here, but in new developments, new subdivisions that they're building, where you might have a slower build out rate than was originally expected. And so a couple of things will happen. If you design a system for 100 homes and in the first year you only build 5, now you're not going to have that scrubbing velocity, right? So some places choose to pig. It's hard to pig a 2-inch line, like to find a 2-inch pig and actually get that through. What some communities, a lot of communities do on the small ones like that, is they'll use a water flush. It's hard to predict exactly how often you'd have to do it, because it really depends so much on what's the build out rate, how far apart are they, right? There's just so many factors that I couldn't stand here and say it's going to be at this frequency and that type of thing, because it really varies on what's happening. Now, in a system like this, where you'd have all community, all the buildings coming on at the same time, we'd be building the system. We design it for the 2 feet per second, and you should be able to avoid that cleaning out.
I'm not sure how many of these homes are second homes, what the occupancy rate is. That's why I asked the question.
Sure.
It can be pretty low, like to drive down the street at night, there aren't a lot of lights on sometimes.
Sure.
Maybe that's because the power's not. So it is kind of a not built out, when you say 160 homes.
Yep.
Maybe half of them are occupied at any point in time.
Sure.
And then to put a finer point on that, and then some of them will have 20 people for the weekend.
Sure. Yeah, exactly. But yeah, you could use a water truck. I don't know, Bob, have you ever had to pig the lines over it? Right.
We've never had to do that, even on the slower periods. It's just not likely. And if we did, the easiest way to do it is to water jet. That's the simplest, fastest way to do it. Yeah, and very costly.
So you said you had up to you could give this community a 5-year warranty. Do you, what's the expected service lifetime of these grinder pumps, and do you have service contracts that you offer?
For anybody on Zoom, the question was, what is the expected life cycle of the pump? What happens if it does need maintenance? Is there service contracts available? As the manufacturer, we ourselves don't do the service. It would be our local distributor. So for your folks, it would be Engineered Systems. Engineered Systems does offer service contracts with, there are 3 different companies here on the island that are certified service people. They've gone through the EOne service certification. So that's something that Engineered Systems could certainly help you guys get set up. The lifespan of the pump itself, the pump body, it should last you 25 plus years. It was designed originally as an appliance. And so they've tried to make it as maintenance free as possible. When you first install your system and start it up, you should not, the average mean time before you're going to need a service call is 10 to 12 years. There's no annual maintenance required. Yeah, there's homeowner guidance we've got at the back that might answer that question. You'll have it in writing. But yeah, 10 to 12 years is kind of that average mean time before you're going to need your first service call. It'll get repaired, it'll go back in the tank and should last you another 10 to 12 years.
Yeah, the reason this community is having to wean ourselves off of cesspool and septic tanks is because just almost a stone's throw from here, we have this incredible ocean reef ecosystem, and that's the main reason we're having to do this. So can you speak a little bit about the safety record for this system?
It's one of the, actually, the question is about safety record and keeping, basically we're trying to keep sewage out of the water, right? That's our goal too. That, when you think about our roots and that stormwater separation project, I mean, that's kind of where we all began. The advantage actually to a pressure sewer system is that it is a sealed system. You think about a gravity system, you have manholes in the street, and there are no manholes in a pressure sewer system at all. It's sealed against infiltration, and also then exfiltration. Right, so you've got HDP material is always what we recommend for pipes. It fuses very well in the field if it has to. They can use, it's quite flexible, so you can have a very long commercially available run of pipe without having any fuses. So now you don't actually have any penetrations that are going to allow the sewage to come out. If you have a homeowner, and I know we come back to that question about what about people that don't take care of their equipment? What about people that flush things that they shouldn't be flushing? Again, we've already said that problem is going to remain in that person's yard. They would have to keep using their toilets and their sinks and their washing machines for a fair period of time before it's ever going to become a problem. And if there is, an overflow, if you will, it's going to overflow onto their yard or back into their house, right? It's not going out of the ocean. The whole system is designed to keep the sewage separate from the water. We're also designed to be in high water table environments. The way that, for our engineers, when they look at how are we going, what are the ballast calculations on the tank to make sure it's not going to pop up in a high water event. We do all our calculations, assuming that the hole that you're going to put that tank in is already to the rim full of water. So we've designed it all that the sewage stays in the system and it doesn't go out into the water. Good question, though.
We've had recent floods where this whole street was underwater.
Absolutely. Yeah. So what you see with the lid that you'll see here, that's in generally, that's our kind of our standard lid. We are in a lot of different places where we call it a high floodplain zone. We do have the option of a floodplain lid that goes over the top, and it is completely sealed. It's a gasketed 16 bolt hole pattern lid that won't allow any of that flood water to come in. No, we're designed to be in completely flooded areas.
What about a homeowner that's not, that the system sits vacant for 2 weeks, 3 weeks, a month? Does that cause any damage to the system itself?
It won't cause damage to your community's system. If they have it, if it's still kind of got some sewage in it before they leave, the worst case scenario is that sewage in their tank starts to go septic, and septicity is very corrosive, and it could have an adverse effect on their pump. In that homeowner's guide, and what we always try to do is a lot of homeowner education. If it's a vacation home or sporadic use, what we always recommend to people is fill a bathtub right before you leave. The last thing you do before you're going to get in the car, fill the bathtub with clean water and let it run through. And what that'll do is it'll allow the tank to empty out basically and dilute the sewage, the wastewater. So really what you've got left, the small residual amount left in that tank will in essence be clean water. That's the way you can really make that last long. When you, because we're in a lot of lakeside homes, vacation homes are very common Garmin place to find a pressure sewer system. And so, yeah, we print that right in the homeowner's guide so people know how to best take care of their system. If they choose to not, the only damage they're causing is to their own equipment.
All right, second question's, what does the average homeowner expect for an installation cost?
For the installation
So
cost,
we're gonna hook up, I want my EOne system. Is there a rough cost of what it might cost me to install the pump, hook it up? I have a septic system which I'm gonna abandon,
right?
hook it up to my waste and then take it to the street. Is there a ballpark range of, what does the EOne system tank cost and what's typical installation?
Sure, good question. I'm going to defer to Scotty because he knows local rates far better than I could possibly. So, Scotty, do you mind helping out there?
Typically, a simplex unit like the one you see there is, if we had 160 homes, okay, that unit there would probably run about 10, 12 K, $12,000. And the install, if you get a real fancy installing contractor, it's going to be more. But if you just get a regular local guy, come in with a backhoe, he can install it for roughly about that same amount. So you're looking at about, 20 to 25K for the whole shooting match. And that would probably include enough dollars to accommodate an electrician pulling a line into the panel and then connecting the pump up. So, oh yeah, that would be like if it was a greenfield installation of a cesspool replacement. You'd still have a cost associated with either filling up the cesspool with sand or whatever, and or on a septic tank the same thing. If you leave it in place, you have to fill it up.
Oh, you don't take it out. You just fill it up.
Yeah. Yeah, just abandon it in place and just fill it up with sand or whatever. Because if you don't and then it fails, you're going to have a sinkhole in the middle of your yard.
A lot of this street, they have ATU, aerobic treatment units. Is there any way to retrofit those tanks? Because those people have paid a chunk of change.
Okay, the people actually, if you have a septic tank, you can convert a septic tank into a ATU. But what you need to aerate the wastewater that's in the septic tank. And so there are ways to do that.
We don't want an ATU, we want to use the existing either septic tank or ATU instead of your tank.
Mm-hmm. And okay, you're still going to, okay, the engineer's talking now, okay? Okay, so our goal is to mitigate the detrimental effects of the wastewater that are going into the ocean. And so what you want to do is you want a higher level of treatment for the wastewater above and beyond what the septic tank does, okay? The septic tank in essence is an anaerobic wastewater treatment system. And what happens is that you don't get enough treatment, so the effluent from a septic tank is still pretty nasty. But what you can do is you can take that septic tank and create a aerobic digester inside the septic tank. You're still going to have somebody come in and pump the solids out. But if you use an aerobic system, and there's this thing that you can put into the septic tank to create an aerobic, you have to pull 120 volt power. There's a mixer aerator that you have to put into the tank, and it'll improve the effluent water quality. Now, whether you'll get to what you want to do, or whether you'll improve it enough to improve your shoreline water quality, I can't make a comment.
But I think what you're asking is, can you take the EOne grinder pump and put it in a septic
Yes,
tank?
we want
Sure,
a sewer
sure.
system.
And if you don't mind, I'll jump in on that
Go
one.
ahead and see.
Yeah, if you look at the geometry of the tank, we have designed it, first of all, it's completely circular. And the bottom of the tank is actually sort of beveled a bit. And what that does is it allows all the solids to amass in the center of the tank. That lets them come up the bottom into the suction head of the pump. And that way you're grinding liquids and solids and it's evacuating. So one of the hard things to deal with with a septic tank that exists, very often they're rectangular. What'll happen is the solids themselves will build up in the corners, right? You'll never get the stirring action, if you will, to bring that in. It's a very large volume that you're dealing with, so you wouldn't have the regular on and off cycles that would turn the sewage over often enough that it, to avoid septicity in your tank. Now, I'm going to be out there just because of experience of because I do work in Washington State. And I'll tell you what they've done there in situations where people didn't want to abandon their tanks. It takes grouting, concrete grouting. And they've actually got a drawing that I mean, they're very willing to share that kind of information. That is a drawing I can get for you folks. And they have people that come in and actually grout inside that septic tank. And in essence, they're creating a spherical beveled system of a decent volume that the pump will turn it over often enough to avoid the septicity. So can you? Yes, but you can't effectively do it in just the existing footprint of that tank, right? You're going to make some changes inside that tank to make sure that that you're doing that efficiently.
I guess the question is it any cheaper to use an existing
No.
tank? Okay, so
No.
Yeah, so it might save you a little bit of disruption in your yard
Right.
if you had
Right.
weird situations.
The other thing I've seen people do, and I mean, we'd have to really crunch the numbers on it. I don't think you're ahead, but I've seen people take our tank, put it inside the septic tank because your 4-inch line for the home is already coming in there. I've seen people put the tank in there, but then you're still going to have to backfill around the tank. It's just people that I don't want to put this beside my existing septic tank. So there's all kinds of creative different ways to do it. But we've got to keep the engineering right to make sure that we're accomplishing the right thing.
Okay. These are the kind of creative questions we get.
Absolutely.
That we say,
yeah,
I don't know.
And I assure you, they ask the same questions in Washington, in New Zealand. I totally understand. I mean, I'm a homeowner myself. I'm embarrassed to say where I live. We're pretty rural out in British Columbia in my community. My whole community is still on septic. I am the one carrying the flag to try and do exactly what you guys are doing here. So
at 4 feet above sea level.
No, we're higher up off the river, but I mean, we're not that far out of Vancouver, so our water table is pretty darn high too, right? We're just off the ocean.
Okay. Anybody other questions?
What's the average operating cost for the homeowner? Is it just the electrical?
Yeah, I mean, well, we said, there will be a service call about once every 10 to 12 years, right? And that really is generally to replace the stator, which is the rubber piece, creates the seal that allows the pump to build the pressure and move the fluid out. And at that point, we'd probably change out the pressure switches. See, we don't use floats. I don't know if people know what floats look like. Floats are very kind of rudimentary way to handle to turn a pump on and off. As the water rises, the float comes off, it comes higher, and it turns the pump on. And as the fluid level goes down, the float goes down, turns the pump off. The reason we don't use those is because, especially in a sewage environment, there's fats, oils, greases, stringy solids, everything gets gummed up on it. So instead, inside the pump, we use pressure switches, one on each side. One's the on-off switch, one's a high-level alarm switch, and they have little contactors. So if we're in there, changing out the stator, which is an inexpensive piece, probably change those pressure switches at the same time so that you truly are going to get that next 10 to 12 years. The cost of switches repair out here, I mean, I know what it's like in my area. A stator change will probably run you just ballparking $250. And if you're doing the switches at the same time, that probably is going to add another $300. They're fairly, inexpensive items. We tried to make the wear parts of the pump inexpensive and readily accessible. It's a good question. And then, yeah, just to address the power question, it's a lot because it's a 1 horsepower motor. It's going to run for 60 seconds at a time. In the end, over a year, it averages about the same as like a garage door opener. Yeah, it's pretty efficient. You guys ask great questions. I love that.
We've been at this a while.
Right, that's right.
Okay,
Perfect.
thank you.
And thank you to Scotty and Quentin and Bob. I super appreciate your help. And thank you guys for asking the questions. Let's get it all discussed at the beginning, right?
Yeah, thank you very much.
Okay.
Two weeks here, 5 o'clock. Where? Our representative at the church.
George, what time?
Where? So it's our state rep, Nicole Lowen. And she was I don't know if she was the chair, but she was a key player on the sexual conversion working.
Everybody take it.
At the state rep. So she's up on the top.
Oh, and just a reminder, and folks are leaving the building. If you go to the left, you will see that we have a fake rock with a lid underneath it. You might, if you stop and take a look, you can actually see what that's like. Oh, I'm glad you liked it. Thank you so much for inviting me. And like I said, if we need to do I'm not, admittedly, our organization uses Teams all the time. So it might be that I'm a bit of a, I will perfectly say it was probably operator error on my part. But yeah, I'll get it, because I know you guys do a newsletter. So what I'll do is I'll make sure that, are you the person to give the links to? Because these videos are right there on our website. People can still go in and look.
Yeah, you can give it to me or Barbara.
Okay.
But you got my address.
I do. Yeah. So and I'll just give you the link and then people can go in there and look at it at their leisure.